Good afternoon, everybody. We are in Algebra 1 discussing quadratic functions. Say hello, Mr. Walker.
Hello, Mr. Walker.
Say hello, Miss Peters.
Hello.
They're in the room with me, so if they get excited about quadratic functions and start running around and having a party, everybody please just excuse them. I know that quadratic functions are, a little more than what some people can handle on a Tuesday afternoon. So, our quadratic functions are in the form of y equals, excuse me, ax squared plus bx plus c. Our first quadratic function that we are going to work with today is y equals 2x squared plus 4x minus 3. Today in class we talked about two major things. One, we talked about our axis of symmetry. We find our axis of symmetry by saying x equals negative b over 2a. Well, before we can do this, we have to figure out what our a is, our b, and our c. I know we don't need c right now, but we're going to keep it in mind. Our a is equal to 2. It's the coefficient of the x squared. Our b is equal to 4. And our c is equal to negative 3. If we plug in, we have a negative, and our b is 4. So 4 over 2 times 2. Negative 4 just stays negative 4. And 2 times 2 is 4. Negative 4 divided by 4 is negative 1. So we can see that our axis of symmetry is negative 1. We also can look at our leading coefficient, this a out here, the a in front of the x squared. That is going to tell us whether we have a maximum or a minimum. In this case, our a is 2, so it is greater than 0. Anytime a is greater than 0, our parabola is going to be in its normal shape. And so it actually has a minimum. So we know our axis of symmetry is x equals negative 1, and we have a minimum. Please understand, ladies and gentlemen, that if you tell me the axis of symmetry is just negative 1, I will not give you full credit. It is not a number, it is a vertical line. The axis of symmetry is a vertical line that cuts the parabola directly down the middle. So you have to know that it is in the form of x equals a number. Now you know why I've been talking about vertical lines all year. One of the reasons we can use them. Let's try another problem. Number 2. If we have y equals negative x squared plus 6x plus 4. Two things we need to talk about. The first is our axis of symmetry. Our function is in the form of ax squared plus bx plus c, and the axis of symmetry cuts straight down the middle. X equals negative b over 2a is always, 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 always the formula that we are going to use to find the axis of symmetry. This is like a y equals mx plus b, ladies and gentlemen. We have to know this. This needs to be put in that long-term memory. We can look at our function and see that a is the coefficient of the x squared, which is -1. B is the coefficient of the x, which is 6. And C is the coefficient, or the constant at the end, in this case, which is 4. So I plug in and I get -6 divided by 2 times -1. An opposite of 6, or -6, and 2 times -1 is -2. A negative divided by a negative, shout out to Zach, is a positive, and 6 divided by 2 is 3. So x is equal to 3. Here is your axis of symmetry. Yay! Now we have to talk about whether we have a maximum or minimum. Our maximum or minimum is determined by the a. If the a is greater than 1, it is U-shaped. If the a is less than 1, which is what we have here, our a is -1. No, pardon me, I said 1, but I meant 0. If a is less than 0, then we have a parabola which is flipped upside down. And our parabola is going to have a maximum. I need you to see in your head, here's my parabola, upside down, and I still have a vertical axis of symmetry going down through the middle. If you have a question, please be prepared to ask me about this tomorrow, because I'm going to expect that we know how to find the axis of symmetry and to determine whether we have a maximum or a minimum. Number 3. If we have a maximum or a minimum, we know we have a parabola, and the next question I want to use is y equals x squared plus 4x plus 3. Axis of symmetry. The axis of symmetry is found using x equals -b over 2a. My a, b, and c come from writing my quadratic function in the form of ax squared plus bx plus c. If I just have one x squared, I just see x squared, then that means this coefficient here is 1. B is 4, and C is 3. When I plug in, I get -4 divided by 2 times 1. -4, and I should have put parentheses around that. It's still going to give me -4 divided by 2, which gives me an axis of symmetry of x equals -2. If I want to determine whether I have a maximum or a minimum, I have to look at my a, and my a is positive. My a is positive, so that means a is greater than 0. And that is meaning my parabola is in the normal shape, having a minimum. We have three quadratic functions that we have looked at. We can find the axis of symmetry. It is a line that cuts down the middle of our parabola. And we can see very clearly that our parabola stops and has a minimum at the bottom. Here, our parabola is flipped upside down, but our axis of symmetry goes right down the middle of it. And here, our parabola is in the regular U shape, but no matter where what our parabola looks like, that axis of symmetry goes right down the middle. Tomorrow, we are going to talk about another special part of our quadratic functions. All quadratic functions have a maximum or a minimum, and it is always on the axis of symmetry. It is a point that is on the axis of symmetry and on the parabola. That axis of symmetry always cuts right down the middle, and this point is always on the axis of symmetry. It has a special name. The special name is a vertex. It doesn't matter if our parabola is in the standard form, U-shaped, or if it's flipped upside down. That vertex is going to be our maximum or minimum, and it is always, always, always found on the axis of symmetry. Here's where I would put my vertex. Here. So the magic word to get into Miss Baker's class tomorrow is going to be vertex. You better know how to find the axis of symmetry, and you better know that the axis of symmetry cuts through the vertex, which is going to be your maximum or minimum. We're going to talk about finding a vertex coordinates tomorrow. They are very important. We have already talked about how to graph a quadratic function, finding points for a quadratic function, finding our axis of symmetry for our quadratic function, determining if it has a maximum or minimum, and tomorrow we are going to add in how to find the coordinates of a vertex. Have a great night.